Hello everybody, welcome back. There are a few things that we have to first of all talk about. First thing, my webcam isn't working, so it's out of order. Hence, I won't be able to show myself. The microphone is still working. I hope I'm audible right now. I'm not sure, but yeah, the camera isn't. So this is the first thing, and the second thing is that I am here live after 5 days. So 5 days ago, it was day 172. It's one, and it's today 117. That simply means 177 day. Okay, and let's simply continue with this. I hope I'm audible right now. Just a minute. Am I audible? Simply continue with this. I hope I'm audible right now. Okay, I am audible. So okay, without any further delay, let's get started. And the thing that we are gonna be talking about, that is nothing but HLD, high level design. I try to cover videos, like it's not like I haven't been, though I haven't been going live, but I still have been learning. Okay, so right now, if we actually click on planning here, there are a few things that we have to just simply go through, and especially in this particular section, this HLD and SHLD, let's forget about this. Mainly we are going to be talking about this HLD section right now, and we have to just simply go through all the concepts that I've actually learned so far. Almost I have gone through all the videos that were there. So ultimately, let's see what all we've learned and how it's going to be all about, and then remaining things are going to be covered sequentially. Okay, as for right now, let's simply go through my notes. Again, I will be going through my notes only. I will try my level best to explain some of the things, and this is how things are gonna be going ahead. Okay, this is not DevOps, not even unit section. There are a lot of things that I'm going through, so these are not the ones. System design, HLD. Ultimately, 12 videos I watched on this particular topic, and I made proper notes, and now it's time to just simply go through them. So let's simply start it from scratch only. Let's start talking about the things, and meanwhile I'm just gonna be summarizing everything, so it's gonna be like that. It will not be like I'm just simply going through that. I will be summarizing whatever I'm gonna be learning here, like I'm gonna be revising or recapping here. So xcalidraw.com. So without any further delay, let's simply get started. First of all, when it comes to intro, so we just simply talked about normal things. Again, they need not be discussed over here. We just simply discussed about normal architecture, how the client server architecture looks like and all, and how you can actually horizontally scale, and what all exactly happens on the transport layer and application layer. We discussed about all these things. Nothing needs to be discussed here. Let's go to the next one. That is in the second one, we just simply discussed about architecture, and from here things get interesting. So even in this architectural section, so first of all, simple client server architecture, we have already gone through it. Okay, so ultimately what happens over here, that there is a client, there are different tiers. There is a client tier, there is a web server tier, there could be DB tier. These are the things. So ultimately client sends a request to the web server just simply responds back. This is how it just simply goes on. We introduced DB as well over here. Then we introduced multiple servers, because when there was a single DB, there was a single point of failure. So we horizontally scaled DB as well. So we implemented something called sharding. So we will be talking about it. So DB scaling, how DB scale. This is just the overall idea about how the things are gonna be working and all. So ultimately, there are gonna be multiple servers. There are gonna be multiple DBs as well. And when you actually horizontally scale DB, so at that time there is something called master slave architecture that is also used. Having said that, again, I'm not going to be talking about that right now. That's pretty simple ultimately when it comes to master level architecture. So you write on the master database, and the data in master database that gets synced in the slave database, and from the slave database you just simply read. So you make a request to read the data to the to slave databases. And then there is something called cache. Cache in the sense, whenever your server make a request, wants to get some data. So first of all, it will check the data in the cache. If the data is there, that's great. If the data is not in the cache, then it will fetch the data from the DB tier. Again, there are many algorithms actually, especially when it comes to load balancer. So there are algorithms for the load balancer. When it comes to ultimately horizontally scaling the server, there are rules for it. When it comes to horizontally scaling the database, there are rules for it. Similarly, For the caching, there are rules. Even for caching, there are rules for rate limiting and all. So there are rules for everything, and we will be just simply having a quick recap and going through all those things really quickly. And apart from this particular thing, then we discussed about CDN. CDN is pretty simple. Ultimately, if you have some static files, and also you can just simply store it, and the CDN will just simply make them accessible. And yeah, we have gone through it. Auto scaling servers, shared DB. We already talked about that. We can actually horizontally scale the database as well. And apart from this particular thing, this all happens when you are in one data center. There can be multiple data centers throughout the world. Hence, uh, you will have a top level, I mean global level load balancer over here. So global level, there are different types of load balancers. One of them is global level load balancer, that is simply responsible for redirecting on the global level, and then in the data centers you will have different load balancers as well. So this is how things are gonna be going on. And lastly, there is something called messaging queue. Ultimately, what happens in the messaging queue is that you just simply give a kind of produce, not even produce. There is a publisher and there is a consumer, and publisher just simply publishes the tasks. Consumer, ultimately worker, is responsible for just simply processing them. This is even called publisher and subscriber model. And then sharding, we have already gone through it. There are different things when it comes to sharding, like when you have different databases, so how will you make sure that which database should be used at this point of time? For that thing, you can use data denormalization. Simply put that, you will be getting some kind of IP address over here. You will just simply pass that IP address through some hash function, then you will get a number, and then you will get the mod of that number by the number of the databases. And then once you got a particular number, suppose 0 1 2 3 4, on the basis of that particular number, databases are gonna be assigned. So this is how the overall things go on. So we have sort of, I mean, of course I haven't discussed quite in detail. From 9 to 11 12, these are the four things that are completely new, like I've never talked about them. Remaining things, the top ones, I have gone through them, so that is why I will be just simply having a quick recap. That is it. Okay, then we started talking about cap theorem. Cap theorem is pretty simple. C stands for consistency, A stands for availability, and P stands for partition tolerance. Partition tolerance in the sense, whenever you make your request to the database, it should return you some data. Ultimately, it should be operatable. It should be up and running all the time. So of course you want your database to be up and running all the time. So ultimately you should be getting some kind of data. And the second thing is that partition. Just a minute. I must have mentioned it here as well. So let's even go through exactly how many things I've covered. So LSSL, oh, I forgotten the full form. There is something called SLI, and then compared with SLO, and then it shows SLA. So these are, when it comes to getting availability, like 100% availability, of course that cannot be possible, but near to 100% availability. So there are these, first of all we measure exactly how much we want, then we have a target, so we compare it with the target, and once that is compared, then we see what kind of promises we should be making. Having said that, what are the full forms of these, I'll have to figure it out. So SLI full form in what? Cap theorem. SLI doesn't know. Okay. Service level indicator. So this is nothing but service level indicator. So service level indicator. This is the first one, and then service level. There are different things, right? SLO. Ultimately, what it is saying, in the context of cap theorem, SLI does not typically refer to standard widely recognized term in the core, which stands for consistency, availability, and partition. That is right. However, it is common for SLI service level indicator to be used alongside a cap theorem design and site reliability. Okay, that's fine. SLO full form. Service level objective. So there are some indicators, then there are some objectives as well. So service level objective. One thing I forgot, if I'm not wrong, just give me a second. Okay, I haven't. I hope I'm audible.
Let's get started. And
yeah. Okay, just give a moment. Alrighty, welcome back and let's continue. So what I was just simply saying, let's close this. What is this? Oh my mistake for upgrade failed to get logged. Please make sure that no other process is trying to update. Oh my bash and remove home. Oh my just a minute, give me a second. What does it mean? Again, as for these lessons that I have, ultimately 12 lessons are here. I have to go through each of them, and if needed, I'm gonna be taking the help of AI to understand it even better. But yeah, we have to just simply go through them. Let's simply check out the meaning of it. So this either simply means oh by share things another updates process is already running, so it created a log file and now refuses to continue. But in most cases the process is not actually running, the log file is just left behind. Say if remove wash this and then try again upgrade if you were updating manually. So ultimately we have to just simply run this command to remove the file, right? So remove oh my bash log update log. Okay, this is the file that needs to be removed, right? It is just simply saying that cannot remove because it is a directory. Okay, if it is a directory, do it like this. Turns out it got done. Let me just simply write again. Yeah, it doesn't really bother it. Alrighty, by the way, let's continue. So I was just simply here. So the first one is a SLI, service level indicator. So like what kind of indicators we have for our application, and then compared with service level objective. So it is compared with this particular one. These are nothing but sort of targets. So you have measured value, you have the indicator value, exactly real value that you have, real measured value that you got, and then you have target value objective, exactly this much it should be, and then you have promises, like what exactly promise you made. So if you have made the promise like my website is gonna be up for 99.9% of the time, that simply means this is your promise. That means in a year your website can be down for 8.7 hours or something. Apart from this particular thing, your target is target could be 99.99%, and your measured value could be around 99.9, probably 5 or something, or it could be anywhere between that. Okay, within that range. So this is how it's gonna be going on. Then availability is gonna be successful request divided by total request multiplied by 100. That simply means 50 divided by 100. Total request, if I sent 100, then a successful request were 50 and multiplied by 100. So it's gonna be all about 50%. So this way I can just simply get the calculation, like percentage. We've already talked about this consistency, availability, and partition. We can partition tolerance or application should always be operate. Ultimately, it should be always up. This is the first thing, and then are two things: consistency and availability. That simply means consistency means all the time you will be getting the same data. Availability means you may get the consistency means you will be getting the new data all the time, and availability means you may get the stale data, but you will definitely get some data altogether. So this is how it just simply goes on. We have already gone through this thing. So consistency, response up to date. Okay, gone through this, and 100% available. We've gone through this as well. There is something called back of the envelope calculation. We are not going to be talking about it right now because it's pretty simple, especially when it comes to the back of the envelope calculation. So there are a few things that you have to keep in mind. First of all, you have to just simply estimate in the sense estimate the daily active users down, and then monthly active, forget about even monthly active users, daily active users, and what should be query per second. These things you will have to actually calculate. So what should be query per second, what should be the storage, how much storage is gonna be needed for 5 years down the line. So this is how the things go on, and again this is something that has already been discussed earlier, so we'll not be talking about it. Then there are services, monolithic versus microservices. Again, pretty simple. Monolith, the way you have been writing the code in one server or something, one file or something. Microservices in the sense you are getting different services for different parts of the app. So ultimately, for different processes, ultimately for different services, you are actually creating different servers. This is how it's going to be going on. And I'm actually getting a call. Just a minute. Give me a moment. Alrighty, welcome back, and let's continue. So I was just simply talking about this, and apart from this particular thing, what is mentioned here, microservices, we have already gone through this. Like there are gonna be different microservices. Not even that, there are different kind of ways to create the microservices. So when it comes to microservices, so they can be actually, first of all, these are the things that you have to keep in mind: decomposition, database, and communication. Decomposition in the sense you will be converting you are converting your code from monolithic to microservices. This is the first thing. Databases, you may be using shared DB or unique DB. Most of the time you will have to use a shared DB over here. Communication, how those services are going to be talking to each other. So these are the few things that you have to keep in mind. Then deployment and observability. Again, this comes under DevOps, so you don't really need to worry about that. And the decomposition phase, there are three phases actually: decomposition, database, and communication. When it comes to decomposition, so of course you have to convert your monolithic code into microservices, and there are actually two ways here: decomposition by business logic or decomposition by subdomains. Business logic in the sense there are different logics, like there is auth logic, there is probably fetching logic, I mean posting logic, not even like that. There are different logics in the sense there is logic for payment, there is logic for order, probably there is logic for auth. You are going to be keeping all those logics separately, and you will be creating microservices. The second thing is that you are going to be actually sort of creating services, microservices based on their subdomains. So that is also possible. So different subdomains will have different microservices. So this is how it's going to be going on, and we've already gone through this. And yeah, this particular thing shows that you don't have to just directly convert your code from monolithic to microservices, because some things may work, some things may not work. Hence you have to uh, convert your code from monolith to microservices one by one, service by service, so that if something goes wrong, you are able to just simply get that thing right. And then there is something called DB partition. It's pretty simple. There can be unique DB. So when there is a unique DB, there is a single point of failure. It's pretty simple. And then there can be multiple DBs as well. There can be many services. They may be using multiple databases. But there are few problems over here. First of all, join problem. Like if I want to get the data combine from all the databases. So how will I be getting them? And if I'm actually saving the data, so suppose I saved in this one and I saved in this one, but in the last one the transaction failed, ultimately the query failed, so it should be rolled back, right? So these are the two things that we have to just simply take care of. So when it comes to reading the data, like joining, for joining we can use a separated DB. So we have three separate DBs, then we will have a shared DB, so that will be connected to this all of them, and using that database we will be just simply reading. So joining is not a problem. As for the transaction, there are some algorithms. If we just simply use them, this problem will also be solved. Not, cannot say algorithm sort of wage that we have over here. So it actually happens over here that whenever something gets saved in the database, we just simply emit an event. So if something got saved successfully, then we will be we will be emitting the event saying it got done or something. And similarly, if something got saved in the payment section, payment database, okay, emitted the event. And if something got suppose something went wrong in the restaurant database, so it will be emitting an event, and that event will be mainly saying that something went wrong, hence you have to roll back in all the database queries that you made. Hence it will be just simply rolling back the payments results whatever you saved, and payment will be emitting an event to the order to just simply roll the whatever we've saved in the database back. Okay, so this is how it's gonna be going on. So this is the one of the first ways. The simple thing is that if something goes wrong, an event will be triggered. On the basis of that event, other databases they will just simply roll back the data. So this is the first thing. The another thing is that you will have a orchestrator at the top. So orchestrator is mainly used for managing this stuff and all. So over here orchestrator will be used for managing the databases. So there's gonna be a top level orchestrator, and when there's the top level orchestrator, it will just make sure that data is saved successfully. If data fails to save, in that case, the whole queries it has made will be rolled back. So this is how it's gonna be going on. Cors command, what is this? Master level, slave level. Okay, this is all about read, how you are gonna be reading, because there are different databases, so it would be hard to just simply join all the tables together. Hence you are gonna be using a common table that will be synced to all, and from here you will be just simply able to read that. Okay, so this is how it's gonna be going on. These are some of the short forms. By the way, DAO daily active users, MAU monthly active users, and total addressable market, that's gonna be 10. And this is what I wrote here for just summarizing purpose. Different phases of microservices, decomposition, monolith, microservices. From monolith to microservice, you just decomposition. You can decomposition by business logic or by subdomains. There can be different types of databases, shared DB and unique DB. When it comes to communication, so API or event-driven system. So API in the sense that's gonna be top level orchestrator or something. Event-driven system in the sense if something goes wrong, it will just simply emit an event. Unique DB, event-driven system or orchestrator. Ultimately, then if you want to use unique DB to all, if that is a shared DB, then you don't really need to worry about that. But if that is a unique DB, then of course you will either use event-driven system or orchestrator, and it will be mainly responsible for managing transactions. And then we have master-slave architecture, especially when it comes to joining. So if you are worried how the transaction will be handled, so you will be using a event-driven system or architecture. And if you are worried about joining, so you are gonna be using master-slave architecture in that particular case. So we've sort of gone through this as well. Again, we will be just simply going through at least those things which we've already gone through like this, and the last 4 ones are gonna be kind of will be gone through thoroughly. Okay, so we have DB sharding and load balancer. It's again pretty simple. When it comes to DB sharding, so we have to just simply horizontally scale the database. When it comes to load balancer, so there are different algorithms for the load balancer to just simply kind of balance the load. So we are gonna be just simply going through them. And when it comes to sharding the database is pretty simple. First of all, from the server you are gonna be getting a request, and there can be IP address. So ultimately you will have your own IP address, right? So whenever the request comes to the server, so that particular IP address, or that can actually be anything for that sake. That can be user ID, or most of the time that is where is that? Okay, I haven't really saved it here, but ultimately that can be IP address or that can be user ID. That's gonna be hashed through the function, hashed through a hash function, and then in the result you are gonna be getting a number. You will be just simply getting the modulo by the number of the databases that you have. Hence, you will be getting the numbers within the range, like as many numbers as I mean, you will be getting the range. Uh, Getting the number within the range of the databases. This is how it's going to be going on, and then you can just simply assign the database. So this is how it just simply goes, and this is a better one actually, consistent hashing. We have already talked about this. So ultimately what happens here, that you actually create a hashing, and that hashing is divided into between within some range. It could be 1 to 100, and whatever new IP or new request you get, you just simply hash. Probably you hash the IP address. It depends on exactly what you are going to be going with. So if that can be user ID, that can be IP address, you are just simply going to be hashing it. You will get a number within 100 to 1 to 100 range, and then on the basis of that you can just simply assign the databases. Okay, we have talked sort of enough about this, so no need to worry about it right now. But these types of things that are there, that do exist, so keep them in mind. And from here load balancing starts. And when it comes to load balancing, so you have to take care of many things: scalability, availability, security, responsiveness, and all. And the load balancer even needs to take care of DDoS attacks and all. So these are the things that you really have to keep in mind. And when it comes to algorithms of load balancers, there are static algorithms, there are dynamic algorithms as well. And when it comes to static algorithms, we have round robin algorithm. Round robin in the sense, first of all, the request will go to this one, then this one, then this one. It will keep rounding, kind of keep going in a round format way. This is how it's going to be going on. Then we have weighted round robin algorithm. Weighted round robin algorithm in the sense, the request will be divided on the basis of the weight. So weight in the sense, if that has less capacity, so less requests are gonna be going there. If that has more, so more requests are gonna be going there. We have already talked about this. And then IP hashing, as I said, there can be IP address, or there can be even your user ID. So mostly let's take the IP address over here. So based on the IP address, your hash is gonna be created, and once you have the hash, you will get the mod by the number of the databases. Hence, you will get a number within the range of the database, as many databases there, and then you will be able to assign the database. I mean, a unique database to that particular one. So we have gone through this, and there are different dynamic algorithms as well. List connection method we have. So whichever has the list connection, the request will be sent there. And then we have something called weighted list connection. So in this particular case, what happens that you have the list connection plus weighted. So the weight, you will be getting the ratio of two things. You will be getting the ratio of weight and the connection on the basis of whichever has the least weight and the connection. I mean the ratio ultimately, whichever ratio is less, that will the request will be sent there. And then we have least response time method. Whichever takes the less time, the request will be sent over there. And last but not the least, we have resources method. Ultimately over here what happens that in the servers you have your agents, they are running, and they just simply keep monitoring the servers on the basis of the load and all. They just simply keep giving the logs, and on the basis of those logs and the data, you can decide which request should hit which particular server. So this is how it's going to be going on. So sort of we have gone through this. Let me see if something come on. So we have gone through it all, and let me see if I'm missing something. Resource method we have already gone through. We've already talked about this. There are different types of load balancers. There is application level load balancer that is mainly responsible for sending the request to some applications based on probably HTTP or HTTPS. We have network layer load balancer that is just simply forwards the request based on IP addresses. There are global load balancers that are simply responsible for forwarding the request to the right data center. And there is DNS load balancer that is just simply responsible for forwarding the request to the DNS and getting the your IP address and all. This is how it just simply goes on. Just a minute. Alrighty, just a minute. Give a sec. Alrighty, welcome back. And yeah, when there's no camera, so it feels awkward even for me. But okay, never mind. As I don't have my webcam running, so can't really do anything. Even it's out of order, so I'm not sure whether I'll be able to just simply get it fixed. So yeah, this is how it's gonna be going on, at least for don't know how long, but yeah, this is how it will be. Okay, done drinking water. Let's continue. So we've gone through this. We have hardware. Okay, there are different kind of load balancers. We have talked about the load balancers. These types of load balancers, and they are further categorized into two types. Some of the load balancers are used on the hard level, hard level. What can I say? At hard level, hardware level, and some of them are used on the software level. So when it comes to the hardware level, so of course there are gonna be the data centers and GBs of investing on. Again, I will have to dig deeper into it, but okay, never mind. Software cloud based, so mostly hardware is the data centers and all, and software is the cloud based. So whatever sort of the environment you make, if I'm not wrong, on the cloud, and Amazon Elastic load balancers that we have, so they come in that particular category, and this is how it just simply goes on. Lastly, this is the recap. So recap of algorithms of load balancer. So there are different types of algorithms here. Static load balancer, especially here we talked about two things: DB sharding and load balancer. Especially in the DB sharding, we are going to be using consistent hashing, that is for sure. And in the algorithms of load balancers, we are going to be using round table algorithm. We have already gone through all these things. Let me do one thing, if I can do something like that. We have consistent hashing. I have forgotten writing one thing when it comes to, but okay, never mind. I mean, when it comes to DB sharding, so no doubt consistent hashing is gonna be used there. So this is the next thing that we have gone through. So load balancers and DB sharding. Then there is something called rate limiting. Again, when it comes to rate limiting, so there are algorithms for that. Exactly how this rate limiting is gonna be going on, gonna be implemented. Mainly there are four types of rate limiting algorithms or methods. Call them anything. And the first one is first of all, what am I doing? It's okay, this is just a simple thing, exactly how the rate limiting thing is gonna happen. You can rate limit based on the IP address, user ID, and other primary keys, depends on exactly which one you take. When it comes to algorithms, so these are the five algorithms we have: token bucket, leaky bucket, fixed token, fixed window counter, sliding window log, and sliding window counter. And I will not be talking about any one of these. We have already talked about this. Ultimately, this is the overall summary of this particular lesson. So when it comes to rate limiting, so client side we can leave it on the client side, though this is the first idea, and then server side and middleware on the basis of IP address, user ID, and something else. When it comes to token bucket, so ultimately there is a token generator that simply keeps generating the token, and what happens that whenever a request goes, there is a token pool, if I'm not wrong. Let me see. There is a token container or token pool, that is something token queue. What is that? So there is a bucket, actually we call that a bucket. So ultimately there is a bucket that just simply contains all the tokens, and on the basis of those tokens, if there are tokens, the request will be forwarded, otherwise the request will be dropped. Leaky bucket, it just goes on like this only, but what happens in this particular case, that there is a bucket. In that bucket, ultimately there is a queue. That queue has fixed size, suppose 3 or something. That simply means at a time there can be only 3 requests, and suppose worker can process 2 requests at a time. So the 2 requests are gonna be followed, processed. After that, the space is in the queue is gonna be empty, so new requests are gonna be kind of placed in the, or new requests are gonna be inserted in the queue. But before that, if you get suppose hundreds of requests at the same time, all the requests are gonna be dropped because there's not enough space in the queue. So this is how it happens. Similarly, we have fixed window counter. There is sliding window log. A fixed window counter in the sense there are gonna be fixed intervals, and fixed number of requests are gonna be allowed in those fixed intervals. Sliding window log in the sense you are gonna be maintaining the logs of the requests that you get, and on the basis of those logs, you are gonna be checking how many requests you got within a particular range, and on the basis of that thing, you can just decide whether this request should be allowed or not. Lastly, you have sliding window counter. So it is the combination of these two. So fixed window counter plus sliding window log. So it is the combination of these two So ultimately what happens here, that you have first of all fix the window, suppose window of a minute. So you have fixed the intervals, and then you check whenever you get a request at that time, from there you just simply check how many requests you got in the current window and how many requests you got in the previous window. On the basis of that thing, you can decide whether the request should be sent or, forwarded or not. Alrighty, so these are the things. Again, I know I haven't talked about all these things in detail, but they can be talked about anytime. Having said that, ultimately whenever a client just simply sends a request to you, so there is a rate limiter in the middle. You may be using any one of them. That rate limiter is actually gonna be deciding whether the request should be forwarded to the server, or the request should be I mean and even this rate limiter is gonna be information, like how many requests are allowed at a time, or within a fixed interval. So it will be getting all that information from the any database, or that could be Redis. So over here it is just simply getting the kind of the limits in all whatever data rate limiter needs to just simply limit the request. And then from there can be a database for the rules, and there can be workers that may be fetching the databases in fixed intervals, and they'll be saving in a cache. So rate limiter will get the rules from the cache, it will be get the data from the Redis, and on the basis of that thing it will just simply either let them go, let the request be passed, otherwise just simply drop them. So this is the thing that is sort of covered, and rate limiter can just simply say, let the request go. Second, it can actually forward the request to a messaging queue, and suppose Kafka and workers are going to be responsible for pushing it to the server. It can even drop the request, and lastly it can even send back a response that is 429, that is too many requests. So this is how it just simply goes on. So we have sort of gone through this. Again, there's nothing hard in it. The special things are gonna be starting in this particular section, where we are actually gonna be focusing on the designing stuff and all. So there is something called designing short URL shortener. Actually, we have even talked about this. So ultimately, you will be first of all you are gonna be generating the overall flow. Suppose you will be passing the long URL to the server. Server will be generating the short URL. So this is how it's gonna be going on. Then you will work on the back of the envelope calculation, so BOE, and even before that you will be getting some you will be estimating some data. You will be knowing more about your website. So this is how it's gonna be going on. This is nothing but the back of the envelope calculation. We have gone through it quite enough, so no need to worry about this. And this is nothing but the URLs exactly when you are creating the application shortener. So ultimately URL shortener. So what kind of APIs are gonna be there, and you are gonna be just simply redirecting the user. And there are two types of redirection statuses: 301 and 302. 302 in the sense if you are using 301, so your result or the caching not even like that. Whenever you enter your suppose URL, so that URL is redirected to another one, right? So that result will be cached, so that the request doesn't come to the back server, doesn't hit the server. And if you are using excuse me 302, so that is the temporary redirection. That simply means on the client side the result will not be cached. So this is how it's gonna be going on, and ultimately things are gonna be going on and all like this. And the long URL service short URL, you are gonna be mapping it, that is fine. And especially when it comes to this particular mapping, so you would better what have we gone through with here. Let me see. I think there's gonna be, first of all, they are just simply passing to a hash function, then they'll get a number. And once they have the number, so not even a number, they'll get some kind of a string. So whenever they pass through a hash function, some kind of string is gonna be given, combining the numbers, small and capital letters and all, and that's gonna be kind of the short URL. And when it comes to storing them, we can just simply store them in a key value format. And for storing them in the format of key value, we are actually gonna be using MongoDB. Let me see what we've used over here. So production level app for particular user many request. It's completely up to you exactly what kind of database you are gonna be using over here. You can use MongoDB, you can use SQL, whichever you prefer. And let me see which one is used here. So ultimately we need to save the URL some kind of this format, hence SQL is being used. Okay, that's fine, not really big problem. And we have short URL, we have long URL, we have the ID, and we can even the first thing is that create the short URL based on the IP address. So first of all is that based on the IP address of the user, you are just simply creating the short URL. And the second thing is that based on the long URL, you are creating the short URL. But if you are creating the short URL based on the long URL, then the problem can be that there can be some, I can say, what there can be some duplicate values in the database. Hence, you will have to make sure that whatever the short URL you get, that is actually unique. And for that thing, you can actually use the IP address of the user. But when you are actually using the IP address of the user, in that case that may not be feasible to using the IP address. Will that be okay? Just a minute. So first of all, we are directly using the long URL over here. Over here we are actually using the ID. As for using the IP address of the user is concerned, it may not work because there can be different requests from there. And even if you are using same the IP address, it doesn't really matter. Like even if you are using the IP address, that is not guaranteed. Either you are using the you are passing your long URL through a hash function, or you are passing your IP address through a hash function. Ultimately, there can be duplicate values, and to avoid that, we can use something called the IDs of the SQL table. The good thing is that all the IDs are gonna be new because of course it is unique. And the another thing is that that we have to take care of, that is there should be a ID generator that is responsible for generating the unique IDs. That is it. These are the things that we have to take care of, and then the remaining things are gonna be fine. So ultimately, client just simply sends a request to the load balancer. Load balancer passes to the server. Server will either get the response, result from the cache if that exists. Otherwise, it will make a request to the server. Database. Once getting the result from the database, it will save it in the cache and just simply forward it to the client, and that is it. The job is done. So this job just simply goes on. These are a few things that you have to keep in mind. That first of all, 2 to the power 10 that you have to keep in mind. 2 to the power 10 in the sense it actually starts from kilobytes. So KB actually the smallest unit ultimately sort of. So it actually starts with the KB. So 10 to the power 10 KB, 2 to the power 20, that's gonna be megabyte. So it starts with kilobyte, then megabyte, and it keeps going on, and then gigabyte. Ultimately, it sort of makes sense, right? So 10 to the power 10 gigabyte, kilobyte. 2 to the power 20, that's gonna be megabyte. 2 to the power 30, that's gonna be gigabyte. 2 to the power 40, that's gonna be petabyte, terabyte, 50 petabyte, and 60 exabyte. So 10, that's gonna be kilobyte. So ultimately we get started with KB. Then 20, that's gonna be after KB, MB comes to megabyte. Then 30 gigabyte, 40 terabyte, 50 petabyte, and 60 exabyte. So this is how it's gonna be going on, and that is it. This is what that you have to keep in mind. And a few things: 1000 10 to the power 3, 1 million 10 to the power 6, 1 billion 10 to the power 9, 10 to the power 12, that's gonna be 1 trillion, 15 quadrillion, and 18 quintillion. Okay, we don't really need to worry about that. Alrighty, so ultimately we have sort of gone through this designing shortener URL, and then 6 of them have been covered, 7, 8, 9. Ultimately 6 of them are still remaining, and in this particular section from 7 to 12, actually I'll actually have to go through the things in detail, because so far we've been just simply discussing about these things verbally. So as for right now, it's been 44 minutes, right? I'm just simply gonna, should I take a break or get it done? Let me see what's there is. So in here we are just simply designing a notification system. So first of all, we worked on designing the, what did we design first of all? In the top one, we actually worked on the URL shorteners, and the second one is gonna be notification system. Notification system in the sense we are just simply gonna be sending the notifications. In that particular case, cache is gonna be used, so we are gonna be just simply going through the algorithms of caching. So yeah, this is something that is yet to be discussed, so we are gonna be going through it. These things are these are such things that actually need to be talked about, and probably need to be I need to take the help of AI to just even dig deeper into them. Hence, I'm gonna be back after, suppose, what time is it? 11:30, right? So probably after 10 to 15 minutes, I'm gonna be back again, and we will continue from here till, I mean, whichever section we can reach, because from 7 to we have to go till 12. So